Hi, welcome to watch our channel, and today we are going to solve another Math Olympic Contest problem for primary students. And this question is about the prime numbers. And we are going to identify all the P, Q, and R that satisfies these conditions, okay? So what we are going to find that is three prime numbers P, Q, and R such that, okay, this thing is a multiple of PQR, and we are going to find P plus Q plus R. So during the contest or the competition, okay, usually once you see this question, you will test some small numbers about prime numbers like 2, 3, 5, and 7, and within like 5 or 10 minutes, if you are unlucky, you cannot identify all these prime numbers, then well, probably you need to use some techniques to solve it. But in this case, actually, if you take some time, okay, take a little bit effort, you should be able to find that P equals 2, Q equals 3, and R equals 5. So this one will give you PQ plus QR plus RP minus 1 equals 6 plus 15 plus 10 minus 1, which is 30. And similarly, P times Q times R equals 2 times 3 times 5, which is 30 again. And this condition satisfies, right? 30 is a multiple of 30, right? And so the sum of PQR will be 10. And this is the final answer for this question. But sometimes if you are very unlucky and you are unable to find such solutions, so the only left is to use some techniques to solve it. So in this question, well, so the first thing is that we know that PQR, okay, divides PQ plus QR plus RP minus 1. Okay, we use this notation. For example, okay, the example is like 3 divides 6, okay, or 6 is divided by 3, okay, divisible by 3, and 5 divides 10. It means 10 is divisible by 5, right? 10 equals 5 times 2, and 10 divided by 5 equals 2. So this is the notation, okay, just a straight line. And what we are going to do now, okay, once we know that PQR divides the right hand side thing, and we know that, well, actually we have PQR is less than or equal to PQ plus QR plus RP minus 1. So compare these three terms, we know that the biggest one will be the QR, right? So that means this one is also less than or equal to 3QR minus 1, which is strictly less than 3QR. So this gives us that, well, the answer of P can only be 2. Okay, the next step is that, well, we repeat again, and we put the 2 back to this divisibility. So we have that 2QR divides 2Q plus QR plus 2R minus 1. And we know that, well, if we just take one part like 2, so this means we have 2 divides 2Q plus QR plus 2R minus 1. And when if we take a look of all these terms, 2 divides 2Q, right? Because this is an even number. And also 2 divides by 2R. And therefore we have 2 divides QR minus 1. And what does it say here? So it will give us that we have something like the Q and R are odd numbers. right? So it cannot be 2. It can only be 3, 5, or 7, or even some bigger numbers. And okay, so this is just a small step for us to verify what numbers could be Q and R. So the next step is actually, well, since we have the 2, okay, we test the 2. And similarly, we could test the QR themselves. QR divides 2Q plus QR plus 2R minus 1. So QR is also the divides the QR itself. So which means this gives us QR divides 2Q plus 2R minus 1. Okay, which means we have QR is less than or equal to 2Q plus 2R minus 1. And this will gives us less than or equal to 4R minus 1, which is strictly less than 4R. So we have that Q is less than 4. And we know that Q is an odd number. So we have Q can only be 3. Okay, so now let's go back to the question. We have P equals 2, Q equals 3. So we have 6R divides PQ, which is 6, plus QR, which is 3R, and plus 2R, right? Minus 1. And then we can actually further simplify this divisibility. So we have 6R divides 5 plus 5R. Okay, this means, okay, what will we have is that 6R is less than or equal to 5 plus 5R, and which will gives us R is less than or equals to 5. So from what we know that R is less than or equal to 5, and which means R can only be 3 or 5. So once we test all the possibilities, we find that R equal to 3 is not possible. So the only solution is R equals 5. So then therefore we have R equal to 5, and hence P plus Q plus R equals 10. And there it is. Okay, so to summarize the problem a little bit, the technique that we use is about the number theory, the very basic one. In fact, we use the divisibility, and then from the divisibility we make it to the inequality. So using the inequality, you can bound those prime numbers for this problem, and therefore we can get the answer that we want. And so if you have any questions about this question, just feel free to leave the comment, and I will try my best to answer your questions. Thank you for watching, and see you next time. Bye bye.